Hi everyone, this is Gaurav, and in this today video we are going to learn about network protocols because it's very important to learn about protocols because as a software engineer, first of all, this is a fundamental, not fundamentals. These are like fundamental topics and fundamental for system design because whatever system you will design, you will need to know like what kind of protocol that you are going to use based on the requirements. And there are a lot of other things like uh, uh, you have to make decisions on. And even though in the interview sometimes for very junior roles they ask about the network protocols, and it's help you to also know like what specific component or what specific protocol does what and what's the benefit of them, right? So when you get the requirement, based on that you can take decisions. Now, so these are the two things like where you can apply this network protocol knowledge. So without wasting time, let's get to the topic and let's understand what is network protocols. So first of all, let's in the screen you can see like this is the OSI model that we have. So if you have studied about computer networks, you know that there are 7 layers, right? And even if you don't have, let me explain you don't need to know these layers and stuff like that. We only gonna talk about the application layer and the transport layer. So in OSI model, these are the layers that we have, and these are the kind of data that we handle on each layer. So for example, in application layer, we handle the data. So this is a plain text. Wherever data is written, it's like plain text. So at these three levels, we handle the data in plain text. In transport, there is segments. In network, we call as packets. In data link, we call it as frames. In physical, we call it as bits, right? So as I told you, these are the only two layers that we are going to discuss because these are the two important layers where actually all the kind of protocols as a software engineer you required to make decision. We don't have to deal about the packets, framings and bits because these are actually the hardware level stuff. So these things companies like Cisco or company who was dealing with the hardware has to deal with, right? So we'll only discuss this application and the transport layer. Before that, let's first of all understand what is a protocol. So I hope you know uh, that generally for communication, you should be knowing a common language, right? So protocol is something like that only, where in the protocol we define some kind of language, right? As well as we defined the rules, the set of rules. So protocol is nothing but a language and a set of rules that you are defining. With the help of that, right, what you are doing is that you are establishing the connection, you are establishing connection between two things. So for example, there is one server, right, and there is this server, right? So now this server speaks a different language, this server speaks a different language. That there is no common thing where we can establish the connection or establish the communication between these computers. But if we take a protocol, a single protocol, on top of that we build something and want to establish a connection, we can definitely do that, right? If this computers also speak English and this also speaks English, they can easily communicate, right? So there should be some standard or there should be some standard to be set so that uh, building things on top of that or the communication between two things could be easy, and there would be some set of rules. So by that motive, actually the protocols comes into the picture. And even though this OSI model, because of that only, this OSI model actually exists in this picture because of the standardization, right? So I will just give you a little bit gist about like how why the standardization actually needs, right? So for example, uh, let's suppose if I don't do this standardization, like, right, if I set a standard here, right? For example, there is a HTTP protocol. This is an example. Let's say there is a HTTP protocol, right? On top of that, there are a lot of stylings, there are a lot of guidance has given, right? So the base is same. How the communication happen in HTTP is written, right? How you will send the data, what needs to be shared with them and stuff like that. this is the way you can communicate to the server. So the base is written, right? On top of that, you can add styling, you can add, you can make things on top of that kind of wrapper. So things like that could be done on top of that, and the base will be same. So if someone is, if there is two computers, right? Whether it's built in India, whether it's built on anywhere in this world, they can communicate because there is a standardization in between them. So that's the protocol actually also brings the standardization, a common language where you can talk to, you can establish a connection between two systems. There are some set of rules that you have to follow to establish the connection. So basically this is the meaning of the protocol. So this is all the gist about protocol. Let's move forward with the application and transport layer protocols. Okay, so as I told you, in application layer we have two kinds of protocols. First is server, okay, my bad, it's client server protocol. Now there is the second kind of protocol called as peer to peer protocol, right? Yeah, so in application layer, as I told you, we have two kinds of protocols. There are client server protocols, there is a peer to peer protocol. At transport layer, right? At transport layer, we have only, we have two kinds of protocols. First is UDP and there is a TCP. Now UDP is user datagram protocol. Yeah, so as I told you, we have two kinds of protocols at application layer. The first is client server protocol, the second is peer to peer protocol. Now at transport layer, we have two kinds of protocol. This, the first is UDP, the second is TCP, right? So we discuss very detailed about these also and these also, because now there is further bifurcation, or there are different kinds of client server protocols and peer-to-peer protocols. So let's discuss those first and then we move to the transport layer protocol. So this application layer protocols, what are these protocols? Generally when you do some communication, right? When you do some communication, for example, let's say this is your mobile phone, right? This is, I'm saying, the client. Now there's this server, right? You can say this is the screen. Now this is a laptop, or you can say this is a server, right? Now your client do the call to this, right? But behind the scene, if you see, there are a lot of things happening, right? To establishing this connection with this, right? As I told you, there should be a protocol. Now at application layer protocol, right? At the application layer, not at the hardware layer. Hardware layer, like this transport layer will be something like actually data transferring from this, right? Maintaining this connection actually is happening because of this transport layer. And on top of that, there are some set of rules that you have to follow. There's a set of things like how you have to send the data, how, whether it's a JSON, whether it's be whether it's with on the bit or buffer or something like that, right? How the data will be, what should be the ways to connect them, and how, whether the data should be sent or whether the connection should be lived or not, something like that is handled by the application layer, right? So when you're sending the request to the server, right, there are two things happening. The first of all, the connection maintaining, the transfer that is happening, right? The reliable connection making and the reliable transfer is handled by the transport layer, whereas the rules, the protocols, the other management stuff, right, that is happening is comes under the application layer. Now, as I told you, there are client server protocols. Let's discuss about that. First of all, let me erase this. Okay, cool. Now let's talk about the client server protocol. So I have told you this is a client server protocol, right? Let me make it small. Okay, so this is a client server protocol. let's discuss about first protocol, which is HTTP and HTTPS. The second protocol is called as FTP. The third is SMTP. The fourth that we discuss is the webhook. Now there are a lot of other protocols that we are not going to discuss, because if I discuss all the protocols, that will be very big video, so we don't want that. So we'll discuss only 4, and these are the more popular ones and most used ones, I can say. Now peer-to-peer, there is only one protocol, so I will write peer-to-peer protocol, which is we have one protocol called as WebRTC, right? So let's start with the client server protocols and understand that. I think before that, let me tell you a little bit about the peer-to-peer protocol. So generally what happened in the peer-to-peer protocol is that this is your PC. So you can see PC1. This is some other guy PC, right? PC2. Now actually the connection is happening directly. You are communicating with PC2 directly. There is no a server or something between that, right? Though there is a signaling server to actually match you with this PC2, which is actually sending the data, and you are doing some leeching and seeding, something like that. So the best example here will be the torrent, right? In torrent you have seen like there are leechers and there are seeders. So seeders are the people who actually sharing the data. For example, this PC2 is sharing the data, and PC1 is the leecher, where it is actually taking the data. So WebRTC best example is uTorrent. Another example could be video calls, right? We understand about this later part, but generally peer-to-peer network is that you connecting PC1 or one computer to another computer directly without interfering or without doing anything in between. Yeah, so that's the case. Let's start with the client server protocol, and the first protocol in this list is HTTP, right? So what this HTTP is, it's a hypertext transfer protocol. So as you can see, the name suggests that it's a hypertext transfer protocol. So what it do? It transfers, right? It transfers the plain text. So for example, if you are sending the data, right? If you are sending the data from one computer to another computer, so for example, computer 1 to server, right? If you want to, this is a server, this is a server 1. If you are sending the data from here to this server, you can actually do with HTTP, and the data communication that will happen in the plain text. That's the hypertext transfer protocol basically means that. And why it exists? It exists here because on top of HTTP, there are some protocols that are built on, for example, set of rules that are built on, for example, REST API. You have listened about this, right? They're gRPC, right? And etc. There could be multiples, but more or less we use these things only, REST API, gRPC. Apart from this, there could be multiple protocols that uses HTTP under the hood. But this is out of scope for this video for now. So these are the protocols that actually uses HTTP, and why they uses that? Because HTTP, what it do is that it provide you stateless connection. My bad, not connection. And what do you mean by stateless connection? So stateless connection means that when you are building a connection, right, or when you are like sending the data to some other from client to server, the previous request has no effect onto the ongoing request or the future request. So every request is a single request. There is no effect from previous request or future request to the current request or the future request. So what do I mean about this? About this is that if you are there is a client 1, and client 1 is sending the data, he's sending the data to server 1, right? Now there is a client 2 that is sending the data to server 1, let's say, Now, or even though this is not a good example, let's say client 1 is also sending on the data. Now this client data that he's sending in the first go and the second go, there is no impact, or there is no impact of request 1 to request 2. So this is a request 1, this is a request 2. So there is no impact of request 1 to the request 2. They are totally independent and just they sending the data to the server. So stateless is one of the feature of HTTP. What HTTP actually do, it actually standardize the things, right? So how standardizing the things, like, yeah, so HTTP standardize the things, and standardizing the things, what I mean is that it gives you the opportunity ki on top of that you can build some things, right? And some other protocols, other rules. For example, REST APIs is some of the styling things that we see, the gRPC and stuff like that, right? So it is standardized the things, like if you want to establish a client and server communication, you can use HTTP or HTTPS, the secure version of it. So it is standardized the things. The other things about HTTP is that it don't make connections. So generally, as I told you, like this will, okay, let me erase all these things. My bad. So as I told you that it don't make connections. So what does it mean? The connection making part, as I told you, is not the part of the HTTP, whereas the request sending, how the request should be sent, right? How request goes, right? What are the methods used, right? Now request goes, method used, structure, right? For example, that will be JSON, JSONB, or bits, etc., right? So these are the things that HTTP handles. It handles the request sending procedure, as I told you, right? So stuff like that, and transferring the request actually to the transport layer, and then transport layer will actually deliver it to the another server, right? Or to the server from the client. So that's the thing. One thing that I want to mention here, there are some kind of methods that we get in HTTP that we have to use to actually do the communication with client to server. So for example, there is a method called as get, which is used to get the data from the server. There is a post, there is a put. Post is for actually create the resource. Put is actually to update, replace a resource. Patch is actually to edit a resource, you can say, and delete is for deleting the resource. So these methods should be used here. There is another thing called as payload, right? There is a headers that is maintained. So these all HTTP does that, right? There are params, right? There are queries, right? So these are the HTTP things, right? And I will say a lot of things here is also implemented in REST endpoints. When you make REST endpoints, it's just that you will handle with these things. When you use gRPC, you don't have to do this because gRPC is totally different. Now let's discuss a little bit about the because this is all about HTTP. Like this is how actually HTTP sends the data and helps to like maintain the connections and send the data to the server, or helps to establish the client server connections and sends the data to the plain text. Now let's talk about the REST endpoint little bit, APIs, because there is a confusion between them and the gRPC. Now I will tell you the very good things here, that REST point is nothing but not a protocol, it's just a styling thing, right? How the API will be designed, they decide that, they tells the rule like this is how it will be. Like for example, it should be resource based, right? It also define like the format of the data, for example JSON, right? It also defines what's the good way to design APIs and stuff like that. So it's just that rules, how the API exactly works. If you want to get the data, you should send the request in something like this way and stuff like that. It's just the styling of the APIs, and it's just the designing, how you will design the API. Now gRPC is a totally different thing. It's actually uses under the hood HTTP, and what it do is that it help you to establish the server to server communication, right? And what it do is that rather than actually doing REST point calls, right, rather than doing calls. So for example, if there is a server one and this is the client, right, client will do some HTTP calls, right, to them. In gRPC also the HTTP calls is happening under the hood for the transfer and stuff, but it's not like it will not like something that request will go, the resource will come and then parse and then these things. Actually what gRPC enables is that from server 1, right, what you do from server 2, you can direct from server 1 directly, you can call the function to server 2. So it's enable you the function calling to different servers directly, rather than making it the REST endpoints where both the two systems will seems different, right? So this gRPC is designed by Google for the distributed systems where maintaining these kinds of RESTful API calls is hectic. Rather than doing that, let's build a gRPC protocol which will solve the problem where you directly call the function rather than doing the call to the server. So that's the case. That's a like little bit information about that. You can actually learn about in depth if you want to go about if you want to learn specific things in each of the implementation. Now this is all about the HTTP. I think I have explained you all the things that is required here. Now let's move to the FTP. Like, what is FTP? So the second thing that we discuss is FTP. So FTP is a file transfer protocol. Now what is file transfer protocol? So basically in traditional systems, generally like before actual internet booms and these things, what happens generally is that there are clients, right? So for example, there's a client 2, there's a client, for example, client 3, right? And there is a central file server that is there. For example, this is a server, you can say file server. So now there are some files that are put in here. Now these clients will request to the file, these clients will request to the file, these clients will request to the file, and then they access the file and they work, and then they save the files and stuff like that. That actually happens. Now the best example for the file transfer protocol I will give you is that in some enterprises you have seen that enterprise will have some kind of server. For example, this is, you can say this is an enterprise server, and this feature I think Microsoft provides to the enterprises where there is a file system. So this is a file system where all the files actually present in shape of drives. I think drives or something, like it could be directly the files, or in the case of drives it is separated and stuff like that. But and then clients, right, the clients, the actual user, they actually do the calls to these ones based on the based on their connection, based on their connection, based on their access. They can see these drives and they can go and they can check the files directly here, and also they can directly get the files, and they can actually use this on their system. But but these things are like very highly restricted. Sometimes these clients is only allowed to use some kind of network, either in the office, to actually access these files, or they have to connect to some portal and stuff like that. Verification needs to be done, and then they can access. So this is basically the file transfer protocol, where these transferring the file transfer, the reliability and these things is managed by the file transfer protocol, because actually here you are not transferring the files, you are not transferring the text, general like normal plain text. You are actually transferring the file. So the collision detection and these things needs to be detected here. So the file transfer help us to do that, to reliably transfer the file. So first of all, let's reliably transfers the file, right? So there are two things, like on client generally we install the software called as client file server. So you can say that it could be called anything, like for example it's a, let's say, file system client is one software that needs to be installed on your on the client, and on the server there will be a file server, fs server software that needs to be installed. And then from the client, this fs client will call to this server, get the file and give it to you. You can do the edits and then you can save it. So stuff like that. It also helps us for the collision detection. Now by default in FTTP there is no collision detection that is happening. Generally people use, my bad, let me, detection. So this collision detection, generally companies used to use this protocol, and on top of that they build that so that no two users actually do the changes on that, right? So these are the very traditional systems. Nowadays I think we don't use these. So that's the thing. So this is about the file transfer protocol. Let's quickly see the webhook first. So okay, my bad, I have written webhook but it's not webhook, it's WebSocket. So my bad. So let's say WebSocket, right? So what is WebSocket? So WebSocket is a protocol, right, where where I will explain you with the example. Let's say there is a server, there is a client, and there is another client which is 2, right? So now there is nothing specific happening here on WebSocket. WebSocket could be using HTTP under the hood or stuff like that. But what happened here, generally it solves the problem of continuous polling. Now I will explain what is polling. Let's understand how the WebSocket works. So for example, client 1 needs to send some message to client 2, right? So how they will send? They will first send the data to the server. Server takes it, and when client 2 will be online, it sends the data to it. So note my point is that, first of all, if you want to send some data to client 2, right? So what you have to do? If this server doesn't exist, or WebSocket actually didn't exist, what you need to do is that client 1 continuously listen that whether client 2 is online or not. So you are doing polling every 2 seconds. You are sending whether client 2 is live. Should I send the data? If it is live, then send the data. Now this every 2 second calls polling is actually costing you, rather than it could be client 2 will come 10 hours after 10 hours online. Then you are wasting your bandwidth, the network bandwidth, sending continuously requests to the client 2. To solve this problem, the polling problem, right, we introduced we got this protocol called as WebSocket, which help us to transfer the data, right? To transfer the data in plain, either it would be plain text or it would be, generally it will be plain text only, and you have to pass those data. But this help us to actually reduce the polling thing and sends the data when client connects. Okay, now there are server, right? I will explain you this. There is server this server 1, and let's say there is a server 2, there is a client. Now this client is fetching some weather data. Let's say this is the weather data that you are fetching. Now client want to see the real time weather data. So how you will say? One way is that clients ask for server to the data, but using webhook, what you can do is that when there is an event or when there is something happened, what WebSocket will do is that it will transfer the data to the client 1. if client 1 is connected to server 1. So here what is happening is that you need to make a connection. So there is a single point that you have to make. Client will connect to it, right? Client 1, client 2, client 3 will connect to it, and there will be, if there is any event will come to here, right? Any event. So this is an event, right? What it will do, it will send the data to everyone, or even whoever needs to be receive the data, he will manage that state and he will send it. So this protocol is called as webhook, where there will be a centralized server, as I told you. This is the server, right? Where actually there will be in the WebSocket there will be a, I can say, the room or the connection will be made to the webhook server. You make a connection to this server, and this is a WebSocket connection from the clients. Now when you connect, right, this WebSocket server, what it can do, it can send the data to any one of the client or whoever he wants, which are connected at that point. Now the best example of this is web WhatsApp, any chat application, and I will say is WhatsApp is one example. So now in WhatsApp, how happen? So right, if this is my phone, right, and this is your phone, now you send me some message. This message will go to the server, my phone, your phone, right? Now this server will be connected to this, and then you type the message and then you send it. Now the message will be here and it will be stored. Now after 10 hours you came online and you connected to this server after 10 hours, right? When you come after 10 hours, then only server notice, okay, you are connected. Now let me send this message to you reliably. Now that's what WebSocket helps us to do. We make a connection, WebSocket connection to the server, then the transfers happens. Now here, what exactly happen is that it could be, so in case of WebSocket, right, as you can see that there is a two-way communication happening, right? So that's a benefit of WebSocket, where you can do the two-way communication, where your server is communicating with the server is communicating with you, right? So that's the case. Yeah, so as we discussed about this WebSocket, this is a short description about it, a short knowledge about it. Let's discuss the SMTP. Now in SMTP I will discuss it very short because it's not asked a lot of time like in the interviews, but we need to know because use mailing server, right, a lot. So what happened basically, I will tell you in a very general term, is that generally what happens is that in SMTP it's called as simple mail transfer protocol, right? So generally you see, like, if you send the mail from Gmail to some other ID, other domain, right, for example Outlook, you still receive it, right? So what happening, there is a mail transfer that is happening here. The text and these things is transferred through the mail, right? And this protocol exists because we want the mail transfer to be reliable. It's not like you send the mail and the mail got lost, right? We don't want that. So it's application layer protocol which helps us to make this possible. And how it do generally is that, generally I will give a very short example where we have a Gmail, then there is another server, and there is a Outlook server, right? So now this is something what happened, that Gmail, when you send the mail, right, this mail will go to this client, right? You can say this is SMTP client, this is a SMTP server that is there on the Outlook side. This client will send the details to the SMTP server, and the SMTP server will send the data to Outlook when you come online, right? Or as a notification, however the application has implemented. So this, to sending this data, right, from this SMTP client to SMTP server, these protocols are used. Now this is a very short discussion about it. I will be attaching a link in the description to, if you want to know about this SMTP in depth. Like, there are a lot of things I have skipped here, but if you want to know about them, you can go through it. But simply it's used for the mail transfer, and this is how actually the architecture mostly looks like. But I will attach a doc for specific for this SMTP. Yeah, so the second thing that we have to discuss, so now this is the totally different part. We will discuss about TCP, transmission control protocol. Now these are the transfer protocol. Okay, so where basically actual transfer of the data happens. Now I will tell you how. Now this is actually very helpful when we are making the connections. So I will be drawing some lines, right? I will be inserting some of the space here, right? Let me do that. Okay, let me do that. Let me create the line. That's, I know it's not very straight, but okay. There is another line. You can say is as this is a server, this is a client. From this, right, you will send a request. You will say, so how actually it happens is that this is a client, this is a server. Now UDP, not UDP, TCP. But TCP is a transmission control protocol, is a reliable protocol, reliable and stateless protocol. How it ensures reliability, you will see here. So first of all, it says hi to the server. Now server will say, hey, I got your message. This is acknowledgement for your hi. Now this says, the client says, okay, now connection has built, right? Now what I can say, I will also send acknowledgement कि I have received your acknowledgement. So acknowledgement acts something like this, right? Now again it says now and the data. So here these two parts is the connection establishment is happening. So here we are doing the connection establishment. Here we are actually doing the acknowledgement for the server request, not request, the server response, and then we send the data from the client. Now in transmission control protocol in TCP, basically all the request is all the request is reliable, and all the requests are made in the sequence. The first thing, sequence, the request sequence, the packet sequence, or I can say, my god, okay, we lost this. We'll make this, we make this, right? So the sequencing, I will write it like this. Let me remove this. Yeah, so the sequencing is maintained. Okay, the second thing, the sequencing is maintained. Your data packets are reliably transferred. So what I mean by that is, if there is a packet drop, so for example the data will go, and from the data, when data reaches, it says okay, acknowledgement that data is received. Now there will again a data will go, and there again be acknowledgement will come. right? So something like that will happen in TCP. So TCP gives you two things: the data reliability and the data sequencing or sequenced data, right? Now these are the two things that we have actually done. So TCP does this, but there is a cost of doing it. So what the cost is, that it's slow. Generally TCP is a slow because it has a sequencing stuff. So when you are sending like 1 2 3, the first one will go, then the second will go. If second is dropped, then again you will try, then you will send 3, and something like that happens in the TCP. Because of that, you cannot lose the packet. The data should be reliably delivered, and it should be retried until and unless it sent. So these are the things that TCP provides, and these are the actually the drawback, and the only drawback is the slow thing. Now the second protocol in the transfer layer is UDP, which is user datagram protocol. Now what is the user datagram protocol? So basically this protocol is, first of all, let's discuss this. So UDP provide you, it's not reliable. It's not reliable. The second thing is not reliable. Should I write this? It's not reliable, and the sequencing is not restricted to be same as the sender sequencing. So what do I mean about is, the first thing is it's not reliable. The connection is reliable. The connection is definitely reliable. It's depend on the network connection that you have, but it's not reliable. What do I mean about this is that the packets that you are sending, or the segments that you are sending, is not reliably delivered all time. So what do I mean about this first? So first thing, packets can drop. Second thing, sequencing. If I'm sending 1 2 3, then in front it could be 3 2 1, or it could be 2 is received, 1 is gone, and 3 is received, something like that. So there is no reliability of delivering the packets. There is no sequencing. It could be 3 comes first and then after, something like that could be happening. Or it could be some packets are actually dropped. One good example here is that I think what I would say, your video calling application of this. So your video calling application, in the video calling, you see in some time, if your network is not good, right, you drop some packets, right? Video calling drops some packets. Like if you are at, let's say if you're talking to with them, there is a network issues. What happened after, let's say 1 minute, again the network comes. What will happen? The video starts streaming from that point. It will not actually store, or it will not actually replay the things that are actually gone because of the network losing. Yeah, so that's a point where I will tell you, like there are few protocols, for example, which are built on top of that. For example, WebRTC, some things like used to be for video calling, which is a peer-to-peer networks, right? So generally UDP is used there. In some scenarios like video call application or video game applications and stuff like that will be based on this WebRTC only, because if the packet drops, right, we don't reliably deliver it, right? So WebRTC is one protocol example which comes under this UDP, which uses the UDP. Talking about the TCP, right? all the reliable protocols like HTTP, where the reliability is there, the gRPC is there for the transfer. There are like WebSockets is somewhat could be in the, it's totally depend on the implementation. If you don't if there is no reliability on that, then it can go to the UDP, and if there are reliable, then it could be TCP. But more or less it comes under the TCP, because all the messages and everything, if you talk about the rooms, will be delivered, right? They will not be dropped. So that's the case, and it's totally depend on the implementation. So these are the things, the SMTP and these things will come to this TCP, because they generally on top of that, they are built on top of that, right? So that's the lower form of the transferring things happening. So that's what I want you to explain, is that there are some application level protocols that are built, and under the hood the TCP and UDP works at the transport layer. Now, based on the functionality, like UDP is totally, it's very fast. I forgot to tell you, very fast, right? It's not slow than the TCP, it's very fast. And the fastest reason is this only, that it do not maintain the sequencing, it do not promise the reliability of the delivery. So that's the thing. And WebRTC, I forgot to explain you the peer-to-peer connection. So let's discuss about this, the WebRTC. Let me write it down. WebRTC. So what is WebRTC? WebRTC is the peer-to-peer network protocol. What happened in this protocol is that there is a signaling server, right? Now this signaling server, what it do is that it actually matches you to the different client. So let's suppose we have a client 2, we have a client 1. Now you will connect to the signaling server. Signaling server will route you to the client 2. Now there are a lot of things happening internally. Will not go to too internal to these protocols, but we see at a very high level that these are the two clients. The clients will connect to the signaling server. Signaling server will connect it to the client 2. Now why we require signaling server? Because there should be something should be maintained. So for example, uTorrent, right? In case of uTorrent, when you download the uTorrent, right, there will be one signaling server. Your uTorrent is connected and it working as a signaling server, where if you're downloading some file for somewhere, right, there would be on that server, on that signaling server, there would be some leechers and there would be some seeders, right? Now connecting the leechers and connecting the seeders is what this signaling server does. That's the task of the signaling server. The similar way, the similar example as I told you, the video call application, right? In case of video call application also, you are doing the same thing, where you are connecting one person to another person, and that's also happen through your signaling server only. So for example, if I was doing a Google Meet call to you, under the hood we are using the WebRTC only, because client 1, my computer, is connected to your computer, and that's the underhood protocol is the WebRTC only. So that's the case, and we actually generate the unique URL or meeting code that you generally send to the signaling server. Then signaling server knows, okay, this is the meeting code that this client have, and then the matching is happening. So I hope this is making sense to you. And this is not a very internal about WebRTC, like actually how the packets transfers, how the reliability happens. This is a very deep things. I think you can read about it. I will attach the resource in the comment section, not in the comment section. I will attach it in the comment as well as in the description. So please have a look onto that. And I hope that you like this video. It's a very long video, detailed video, because I don't want to explain things in very shallow way. So that's the thing. Let me know if you have any doubt, or if you want to ask anything regarding this. Yeah, so that's all from my side. Thank you guys for watching it. If you like it, give us a thumbs up, and if you want to subscribe, you can subscribe. Thank you so much. Bye.